Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30pm local time. We'll see you soon. This is VK7 OTC.
This way a little bit. And this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. For the 15th, I think it is, or the 16th? 16th of December. Where is December going? And I have Rex VK7MO in the studio with me. Good evening, Rex.
Good evening, Justin.
And I've got Rex in the studio with some very interesting WSJT news.
Right. I might just go a little bit back in history. Probably a month ago, I think I talked about a new mode called FST and FSTW, which originally Joe thought might be a sort of universal mode that replaced everything.
The Swiss Army knife.
Swiss Army knife. It turned out, when we tried it on things like 10 gigs, that it just didn't cope with the spreading.
Okay.
But we used it for optical, where it was brilliant, like getting down to minus 45 dB.
Wow.
Admittedly, in half-hour...
over half-hour segments, yeah.
Segments. Okay. And Joe promised that he would produce a mode for the EMEers.
Okay.
And only a few days, well, probably a week ago now, he invited a few people to participate in testing what I think would be called a pre-beta version.
Okay.
With a very firm command that if you participated, you had to send him the files.
You had to actually participate.
Yes.
Yes.
And you weren't to distribute the program until it was all sorted out.
Okay.
So people, while I see this as a sort of an appetite wetter, you can't actually go and use it yet.
Yeah. Okay.
But I thought I'd just say a few of the things that we found. We started off testing it. I started off testing it with Peter VK7PD on 1296.
Okay.
And we got down fairly consistently to 50 milliwatts.
Wow. Okay.
in
On 23 centimetres.
on 23 centimetres.
Over what sort of distance?
It's about 160 kilometres,
Okay.
but it's over the mountains in central Tassie.
Yep.
So it's definitely, you know,
Tropospheric ducting.
yes.
Yeah. Okay.
And that was using 300 second segments.
Okay.
Now that looked good. I then was trying to set up some EME, but EME is actually pretty hard to set up because you've got to have the moon up and people have got to be available and
Spreading
not at
has
work.
to be in your favour and...
Well, and it can't be raining at either end because your dishes are no good out in the rain, etc. But finally, a couple of days ago, I started using it on EME with a Californian station. We haven't yet tested it in the long periods, mainly because I'm a bit cautious about my PA.
Yep. So is this mode like FST where you can set the period? Is that...
You can set the period anywhere from 15 seconds to 15, 30, 60, 120 or 300 seconds.
Okay.
And you can set the tone spacing from A to E.
What's that mean?
Well, if you've got a
Sorry, I'll look at you blankly.
okay, if you've got a spread signal,
Yeah.
you need wider tone spacing.
Okay,
And,
okay.
and not only wider tone spacing, but the actual bandwidth of the bins is increased in proportional to the tone spacing.
Okay.
So you get more noise if you
Yep.
if you go for a wider tone spacing.
Okay.
But you can cope with a signal that is spread or not so stable.
Okay.
And so forth. So,
No, okay.
so
No.
essentially it's got lots of options.
Yep.
And it's up to us pre-beta testers to try and work out where these things will be useful
Okay.
and where they won't. So the mode for the same time is really not, well, we're still to determine it, but it's not significantly more sensitive than QRA.
Okay.
But it does have a new sort of sync tone, which is all on the one frequency.
Okay.
The sync tone is not as visible as JT65, which has a 50%
Yep.
sync.
Okay.
This one only uses about 22%
Okay.
sync, but it's still there if the signals are reasonably strong.
Okay.
And hopefully that will encourage some of the lower microwave bands who just wouldn't use QRA because they couldn't see it on the waterfall.
Couldn't actually see it physically.
So they just gave up 2 dB because they wanted to be able to see it.
Okay.
But certainly 10 and 24 gigs we've all been using QRA.
Yeah.
So the big advantage of this is that it can run for longer periods.
Okay.
Now, providing you're prepared to run your PA for longer periods,
Yes.
you ought to be able to pick up 3 dB by going from 60 seconds to 120 seconds,
Yep.
and about 7 dB by going up to 300 seconds,
Okay.
which is going to make sort of QRP type EME
Possible.
possible and much easier. So
Okay.
in that respect, it's good. So far, I've only tested it one way, at 120 seconds, because my colleague in California, he's got a TWT that's actually designed to run continuously.
Okay.
So he's happy enough to run it.
At 300 seconds.
We haven't tested it at 300, but certainly there is an improvement in running it even at 120 seconds.
Okay.
One of the problems at 10 gigs is the way it's set up at the moment. Each time you double the time, you halve the tone spacing.
Okay. Right.
So we really need some more wider tone spacings.
To test that part of the mode. Yeah. Okay.
Particularly at 10 gigs.
Okay.
And
Can you pick where the you can pick the tone spacing?
yes,
Can you pick where that actually is set within that bandpass?
you can, but sort of traditionally we always start with the lowest tone on 1,000 hertz.
Yeah, okay.
And I'm pretty reluctant to move away from that.
No. Well, if that's the standard and the custom and practice, it's...
Yeah. But certainly for the wider tone spacings, some IFs won't cope with them.
Yeah.
And there's an advantage then of, depending on people's rigs, perhaps starting at 700 or 600 hertz.
Yeah, okay.
But you've got to arrange all this in advance and stuff. So
does it listen in the whole bandpass like the other modes? So
yes.
Okay. So it's decoding whatever's in that.
Except that on the wider tone spacing, it's filling that hole.
Yeah, okay. It's the whole bandpass. Yeah,
it's filling the whole bandpass.
Okay.
Now, having tested it on EME and also on troposcatter on 1296, I thought it was worth testing it on 10 gigs troposcatter.
Yeah, okay.
And I set up a sked with RET VK3WE who I had previously.
Yeah. You've previously done the test with him for long periods of time, wasn't it?
That's right.
Yeah.
Probably about 10 years ago.
Yeah.
And I thought, well, if we can get an improvement over that will be interesting. Well, I set up, and Rick just came back and said, "You've got a big signal."
Okay.
And I thought, this can't be troposcatter. There must be ducting or
some other mode.
Something.
Yeah.
And I went and looked at the Hepburn charts, and there was a little bit of a duct at our end.
Okay.
The signal was spread about 1 hertz, so I thought, well, it's probably got to be troposcatter.
Yep.
Because ducting doesn't spread. And I couldn't pick it. And then in the evening, I thought it was still there. It seemed to be spread more.
Okay.
And I thought, I'll have a look at the rain radar.
Guess what?
And there was a little bit of rain.
Okay.
I mean, we haven't had much rain this week, have we?
Not down here,
No.
But I know they've had it up north.
Yeah, well, there was a little bit of rain right up the north end of Bass Strait, near Reed. But Reed couldn't see any rain. And he said, well, it's not wet here, it's all clear.
There you go.
So we thought, well, maybe it's this rain scatter.
Yeah.
And we were getting absolutely consistent signals. I was only getting him about minus 23, minus 24, because he's only around 10 watts.
Yeah.
And he was giving me minus 14s off my 60 watts.
Yeah, okay.
So this was looking really promising. So over about the last 2 or 3 days, we've been trying morning, noon, morning, afternoon, and night.
Yep.
And every time we've got through bar 1. And Red actually copied me on that occasion, but a bit weaker.
Yeah.
But
so that could have been the power difference.
Power difference.
Yeah.
But essentially, for 3 days in a row,
you've actually contacted him consistently.
Consistently.
On 10 gigs, whatever the mode is.
Yeah. Now, we've been playing around with the tone spacing, going from A to E.
Okay.
And we can't work out which is better. They all work.
Right. And there's no big difference between...
No big difference.
Okay.
So, I guess this seems to be a game changer for rain scatter, because most digital modes I've tried to use in the past for rain scatter just cannot cope, because they're so chopped up and spread. They cannot cope. And what it appears to be is the sync tone on this is almost immune to variation.
Yep.
In fact, Joe did say that compared to JT65 sync tone, which if you get a meteor ping in the middle of it, you just don't get a decode.
Yeah. Okay.
he said this is immune to media ping, so it's ideal for sort of working tropo across to ZL, because if you get media pings in the middle,
It doesn't matter.
it doesn't matter.
That's great.
So it appears that this new sync tone, and it's all on one frequency,
Okay.
is a terrific advance, and it's going to make rain scatter on 10 gigs.
Mode of choice.
And yes, and I reckon it's going to be a game changer for rain scatter.
Have you gone back to Joe with the what you found thus far?
I have, yes.
Any response? Any?
I think unfortunately I had a few other little queries in the email, which Joe responded to those queries rather than saying this rain scatter's great stuff.
Okay.
Joe's very matter of fact and focuses on what he needs to focus on.
That's right.
But I wouldn't mind betting he's picking up the idea that this mode is going to, because he never anticipated it. He said it's a good mode for iron scatter on 6 metres.
Yep. Okay.
Where he's been testing it. Sort of 100 watts, 3-element Yagi, consistent copy over 1,000 kilometres.
Yep. Okay.
But and he thought it would be good for tropo scatter and EME. He hadn't thought of rain scatter, which is understandable, and we only found out by accident.
Well and truly.
So
that's remarkable, Rex.
I'm pretty keen to do more testing, but I think it'll be a game changer for.
Well, and your comment about it being this is a QRP, like microwave QRP mode, so we've gone down to even lower levels. Potentially.
I wouldn't say it's certainly at a lower level for EME.
Yeah.
But we don't have I can work RET pretty consistently on rain scatter with his 10 watts.
Yeah.
It's not quite QRP. But
What size dish is he running?
60 centimetre.
Yeah. Okay. Oh. Yeah. Say it for me yet.
Yeah. So, still early days.
Okay. Now, what was the mode called? What was
it's called Q65. Now, the Q is actually shorthand for the same meaning as QRA, which, if I remember rightly, is query repeat accumulate code.
Right. Okay.
and it's another version of a query repeat accumulate code with a different sync.
Okay, and 65 tones, I assume.
And 65 tones.
Yeah.
Well, the sync is the 65th tone,
The 5th tone.
which is actually on the lowest frequency. It's really the first tone.
Okay.
Whereas QRA 64 is 64 tones with the sync
With
all
a sync, a separate sync.
interweaved into those 64.
Yeah, okay.
So,
okay.
Quite promising for EME
Wow.
from the tests I've done so far. Very good for tropo scatter on
96? Yeah.
And surprisingly, I reckon a game changer for rain scatter at 10 gigs.
Fantastic.
Okay.
Now, any idea when this is going to be more generally released? Any indication from Joe?
I think that's not yet even controllable because a lot of people are reporting different problems, including me.
Okay.
I think they're all more programming problems than sensitivity problems, which just have to be resolved. With a pre-beta version, you have to expect that.
Well, pre-beta versions are usually alpha versions, and alpha versions they don't usually release to too many people, if any at all.
That's exactly. So I think whether it takes 2 weeks or 2 months is still up in the air.
Okay, no, that's right. But exciting news otherwise. But it's very good. Okay.
All right.
And any news on the optical front?
Actually, I've got diverted because of this stuff. But I am building my new 96 LED transmitter.
This is the new cloud banner.
Well, it's not focused like the coal burner, but it's got the new LEDs which seem to be about 10 dB more efficient than the ones that we had in the 60s.
So we're increasing from 60 to 96, and they're 10% more.
10 dB.
10 dB. So okay, even more. Okay, sorry, 10 dB more.
So
this
maybe
is
15 dB.
This is definite. This is a cloud scorcher.
Well, it's not really, because the cloud burner had very narrow beamwidth.
Yes. Yeah.
But I suspect very inefficient at the narrow beamwidth.
Yep. Yeah. Okay.
So maybe this is a cloud shatterer.
You heard it first on the DATV night.
Okay.
Very good. Thank you, Rex.
Right.
Thank you. Okay. And we look forward to the release of Q65.
Right.
Fantastic. Thank you, Rex. Okay, we have, and we also, I just remind people, you can call in. That's a good point. We can call in on repeater 2. I'll just actually be listening on repeater 2. And you can also call in on the YouTube chat channel. We do have the streaming up and going tonight, which I apologise for. Last week we didn't, for some reason, have the streaming going, and I really actually don't know why. But tonight it is certainly up and going, and I'm watching the chat channel as well. So the next segment, I'll just hold this up. The next segment, this whip antenna, which is it fully opens up to 1.4 meters. So it's a fairly standard chrome whip antenna, which I came up with a little mounting arrangement for the bit of wood. I usually use this for the practical assessments that we do, that Reg and I do when we do an assessment day. And it's just literally basically an antenna that I can drag out, and it's a portable antenna. It's very easy to set up, and I can just set it up on the bench, and the foundation licensees or whatever can see this is the antenna, and this is the antenna tuning unit, and this is the low pass filter, and this is the transceiver, etc., etc., because they have to be able to demonstrate that they can put those together in the right sequence and plug them all together. And then there is an element of the practical assessment where we have to, at least they need to indicate what levels of SWR is potentially indicating a faulty antenna, potentially indicating that you might want to look at your antenna and what is an acceptable SWR. So you have to be able to, first of all, recognise that. And I suddenly thought, with just a whip antenna, which is pretty short for HF, because we use it to do a HF contact. It's very short and incredibly short for 80 metres, 40 metres and 20 metres. And even the SGC antenna tuning, the automatic antenna tuning unit that I use, the SG211, very nice little battery operated unit with latching relays, basically a black box, will tune. The specifications for it is it will tune an 8-foot whip from 3.5, so 80 metres up to 60 megahertz, up to 6 metres, and tunes a 25-foot antenna from 1.8, so 160 metres up to 60 megahertz, or up to the 6 metre band. So very nice little unit, but even this unit has its limits for a whip that is 1.4 meters long at this maximum, so it doesn't actually tune it very well. So I thought what I need to do is read up first of all around whip antennas, short whip antennas, and come up with an arrangement. And I've stuck with a base loaded whip. So what you're doing is in effect adding a loading coil onto the bottom of this whip antenna to make it electrically look a lot longer. Something that's more acceptable at, and in this case I've made it 80, 40, 20 and 10. There are 4 coils on there, which progressively get less and less number of turns. So I tried to make it so that it is somewhere in the vicinity of 80, 40, 20 and 10, and then we can use the tuner to actually do the last little bit of matching for me. I've also added, actually, and this is where I can probably go over here, and go to the close-up camera. Just bear with me. Okay, there we go. So you can see what I've done. This is the top the top of the whip. This is the tuning coil. I have put a little 100 puff capacitor on here just for those lower frequencies to give me a little bit more of the ability to do some matching. And the way that I switch between the 80, 40, 20 and 10 is a wonderfully simple manual process of a jumper clip going from 80, 40, 20 and 10. And there is a common end to the coils, common end to each of the coils, and then there is the switch end, which I get to with the jumper clip. I do have a counterpoise on here. The counterpoise is 0.05 of a wavelength at the lowest frequency, so that's about 4 or 5 meters at the at 80 meters. And we just had R2 there, a trigger. With some Morse. I have a feeling I know who that is, but anyway. So greetings to our Morse contributor on the repeater. But now what I learnt in going to the internet and having a bit of a look at what is available on the net in relation to whip antennas is probably my fundamental comment here is you need to be a little bit careful about when you go to the internet and try and find bits and pieces in relation to short whip antennas. And in fact, the best source of information for short whip antennas is if you have access to the ARRL antenna handbook. There is a wonderful section in that handbook on exactly that. Under mobile and maritime antennas, HF mobile fundamentals, and it goes into loading coil designs. It goes into the capacitance of the antenna, which you need to take into account, obviously to design that loading coil to compensate for the capacitance of the antenna. The short antenna, it goes into radiation resistance, and then goes into how you calculate all of this. Now, there are some wonderful resources. I said that you have to be careful about the internet, but there are some wonderful resources out there that does take into account a lot of the things that the ARRL handbook talks about. The very first one that I used was to calculate was a whip antenna design calculator, which I should have dug into the website a little bit more. It certainly looked as if they had taken into account a lot of the theory and the formulas that are outlined in the handbook, but I went ahead and it calculated the 80, 40, 20 and 10 frequencies that I wanted. You put in the length of the whip and you put in the diameter of the whip, and it magically calculates the capacitance of the antenna, the tuning inductance, so the inductance, the inductor that you need to base load, quarter wavelength, the antenna length as a percentage of a quarter wavelength, and also it calculates the radiation resistance. So I went ahead and did that, and it gave me the inductance, which you can then put into your inductance calculators of choice. And the one that I actually use, and the one that seems to be the most referenced, is a thing called coil 64 or coil 32. It used to be, as in 32-bit and 64-bit. It does, just let me show you, because I took a screen grab. I could probably actually show you this on the screen, but very nice little application. It gives you the ability. Can I make that a little bit? I'm not sure I can. But it's available on, it's multi-platform, available on Windows, Mac and Linux. So it gives you the ability to select the coil that you're trying to design. So one layer close winding, one layer coil with round wire, one layer with rectangular wire, one layer with a polygonal former, multi-layer coil, etc., etc., a ferrite toroid coil, a PCB flat coil, which is excellent if you're trying to design something on a PCB. It will actually give you the ability to calculate what the inductance of the coil is, which is fantastic. And there is one after this, but there are a couple of Tesla coils. So if you're wanting to create high voltage Tesla coils, there's also a design that enables you to put that in. You then put in the inductance you're looking for, the frequency, the former diameter, the wire diameter, and the wire diameter if it's got insulation on it, and then the type of material that you're actually using for the coil. Push the button and it magically gives you on this side, in this panel, the calculations for it, which look like this. If you this comes up on the screen, but it also you can print it out. So it gives you all of the parameters that you put in, and then the result of the number of turns of that wire around that particular former, with and without leads, the length of the wire that you need to cut to wind it, the reactance of the coil, etc., the self capacitance, and a few of the other parameters that are in there. So really handy little application. So anyway, I put in the various things that I had come up with this whipped antenna designer, and wound the coil. And do you think I could get it to get anywhere near the resonance that I wanted that whip antenna to be at, given the parameters that you end up with on this calculator? And I went, something's a bit dodgy here. Not quite sure what, and I even checked the inductance of the inductors of the coil, and it checked out. It was exactly what it said on here, and I sort of went, that's a bit strange. So anyway, I went searching again to come up with a couple of other whip antenna calculators, which ask you for the same parameters. That's great, but they come up with quite different results for the inductance of the coil. For exactly the same frequency and exactly the same whip length and diameter. So I went ahead and wound it for this one, which is what you see here, and surprise, surprise, I'm somewhere in the ballpark, and with the antenna tuning unit I can get that last little bit, or with the capacitor, the variable capacitor. So So anyway, that's a whip antenna that I will be using for the practicals, yeah, absolutely fascinating. I have to say the capacitance that is calculated for this, I'm not sure is quite right, and the only reason I say that is if I add a bit of capacitance on there by either putting like a top hat on or even holding the antenna, which is of course adding significant capacitance to ground through me, I start to get some better results and can get actually quite good matches. So I'm not sure that the capacitance that has actually been calculated as part of this is quite taking into account that particular antenna. However, we now have a in the ballpark antenna that enables me to demonstrate matching SWR on a very small little portable antenna using HF, so 80, 40, 20 or 10. And when we do the practical, we do some contacts between rooms on the club radio, and also I have the 705 set up, which you can demonstrate the SWR function on the 705, which is really nice. So anyway, just a little bit of a word of caution when you whiz off to the internet and try and accept what these calculators are giving you. What I'd probably say is the one that I ended up with is from a site called Everything RF, and they have a whole bunch of calculators, all seem to be within the ballpark. So I think if the site is not really RF related, or it might just be a calculator, here's a whole lot of calculators that they've pinched from somewhere else or whatever, I'd probably steer clear of it. But anyway, that's a short RF whip. A bit of experimentation I've been doing over the last week, which is some fantastic antenna theory, which is really good. Also, I do recommend a bit of a read of, if you have either the antenna handbook or you have the RSGB or the ARRL handbook, there is a section on these sorts of antennas in those handbooks as well that take into account all the parameters that are there. So, but anyway, that's the antennas that I was just going to show you. One of the other things I was going to let you know about tonight, I mentioned a couple of weeks ago that we had a club project going on around switch mode power supplies. For those of you in the IT industry, you'll recognise these. They are server power supplies. There's usually a couple of these in a server chassis as redundant power supplies. We have been doing a whole lot of infrastructure renewal, and I've managed to get the infrastructure guys to pull all of these out as they throw the server into the e-waste bin. So we have quite a few of these, but one of the things that we've been doing is designing up, because it has an edge card connector on it. What we've been doing is coming up with a little PCB design. This is my mock-up to make sure that things fit and things are in the right spacing and all of that sort of stuff. So that plugs into the edge card connector. What we're actually putting on this PCB is we've managed to find a source of the Anderson PCB mount connectors. So these are the Anderson version of the edge connectors, of the Anderson connectors. The Anderson plastic connector clips on there. This goes into the PCB, and there's a little mounting arrangement where you put a bit of wire around the Anderson connector and solder it into the board to give it a bit of strain relief. That's the top one, and then there is a lower one. There we go. so this is that sits. In fact, what we'll do, because me holding it up doesn't mean a thing, because you probably can't see it. So what you do is there's a spacing that they specify, and one goes above the other. This goes into the PCB, and you solder this in. It gives you the 45 amps of connectivity, so long as obviously the tracks on the PCB are large enough. And you put two of these next to each other, so you basically got two sets of Anderson connectors, and they just make it very neat and tidy, and give you obviously the Anderson connectors to oh, hang on, sorry, wake up, Justin. So there's the two PCB mount Anderson connectors. These solder into the PCB at this level, and the Anderson plastic tops push on to here and click into the Anderson connectors on either side. You put two of these next to each other. One's obviously positive, one's negative, and you then have a PCB mount Anderson connector that you can just plug into the PCB. So it makes it all very neat. The PCB just plugs into the edge card connector, and then there's a couple of these Anderson connectors that stick out the back that give you the connectivity to the rig. So that's what we're working on. The other PCB that we're working on is the just bear with me. The other PCB, here it is. So we have a number of the smaller form factor 750 watt, and I don't know about you, but there's 750 watts you can get out of this. So what we're talking about is 12 volts at, or we can bump up that voltage. 12 volts at 62.5 amps comes out of that. That it's capable of, but it has a 64-way edge card connector on it, so there is that makes it a little bit easier to make. It's a 64-way edge card connector. So if you remember the IDE connectors, I think in your PCs, they were 64-way connectors. So it's about that long. That'll plug into there, and then you will solder onto a PCB that will have the Anderson connectors on it. So we've got 50 or 60 of those, and we've got many more than those of those. So there will be. Stay tuned. There'll be a club email go out about all of that. And we'll have a deal for our club members around high current switch mode power supplies. Watch this space. Now, last weekend we had the WICEN lunchtime. The lunch down at Snug, thanks to Peter VK7 TPE and Maureen. Fantastic lunch cooked by Chris VK7 CDW. He did a fantastic job of the lunch. We had a lamb and a pork roast, and all of the vegetable trimmings that go along with it, and all of the sauces that go along with it. So it was a fantastic lunch, and it was great to see Lakia and Christian down there, who are two recent Foundation licensees scouts from Huonville, where they have a radio group that the five that passed their Foundation license just recently all got a Baofeng handheld the other day. So that was the prize, I suppose you'd say, the incentive at the end of it. They all have a programmed Baofeng handheld that even comes up with their new call signs. That I'll actually bring their call signs up next week. So new call signs. So really good. Reminder about for our Reast members, the membership renewals have gone out. Emails have gone out if you supplied an email address. If not, you will be getting it in the post. And a reminder, next week is the 23rd. So just before Christmas, and invite people up to a Christmas-themed DATV night. So bring along some Christmas cheer or something, and we'll have a bit of a Christmas celebration up here for our DATV night, so on the 23rd. So that's next week. Now, I have to thank Larry, VK7WLH, for a couple of our videos tonight for our RF viewers. There's a wonderful one called Just for Fun, the first drone video from the 1930s. Now, who would have thought that we had drones back in the 1930s? But we did. So I'll just leave it at that. The other one is the first digital video signals, amateur digital video signals, back in 1973. There's an interview between W8KFJ and W6MXV about the first digital video signals that were transmitted in 1973. So some great videos. Thank you, Larry. We also have Ham's "'Twas the Night Before Christmas," of course, because we can't go without that being broadcast. And also Ham Radio Crash Course, the using Christmas lights as a ham radio antenna, and how that goes. So that's our videos for tonight for our RF viewers. So there you go, and acknowledge the CW on R2. So thank you for that particular viewer. So we'll just take a bit of a call out on R2 just to see whether there is anybody who would like to put in a question or a comment. And this is VK7 OTC just putting out a call for our DATV Experimenters Night on repeater 2, and we are listening.
VK7RM. Thanks, Justin.
And VK7RM, VK7 Oscar Tango Charlie. Hello, good evening, Ron. And thank you, Ron, for calling in. Thanks for calling in, Ron. Any other call-ins this evening? Go ahead. No, nothing heard. All right. And nothing come up on the streaming channel, so we'll head into our videos, and we'll catch you next week for our Christmas edition of our DATV Experimenters Night. This is 73 from VK7 OTC. Cheers.